Let us now consider the next concept in this chapter, and that will be the refraction of light through a glass prism. Refraction through a glass prism. A glass prism. So in the last chapter, we discussed refraction through glass slab, right? We took a rectangular glass slab and we saw that light refracts, that is, it bends when it moves from air into the glass slab. It moves towards the normal, then it goes straight, and when it exits the glass slab, it emerges away from the normal and it emerges parallel to the incident ray, right? The emergent ray is parallel to the incident ray with some lateral displacement. But now, refraction in a glass slab, let us see, is it similar? Sorry, in a prism, is it similar to a glass slab? Let us go, we're going to study that now. Before we understand that, let us understand the structure of the two. Right now, you know, rectangular glass slab is rectangular in shape. Okay, it is just a rectangular slab like this. Okay, a cube, semi-cuboidal structure kind of thing. Okay, that's your glass slab. Pretty simple rectangular structure. But if you look into a prism is basically a, a kind of a solid which has a triangular prism here we are seeing. So it has two triangular faces and three rectangular faces. Right, so if you look into a prism, that's what it looks like. There are two rectangular faces. This is one, this is two, and there are two triangular faces and three rectangular faces. So 1, 2, and 3. Right? So this is the structure of a glass prism. And basically the angle between these two sides, okay, these two triangular lateral sides, this angle and this angle, these two angles are called the angle of the prism. Okay, angle of the prism, right? So let us study how refraction takes place when light enters a glass prism. So basically when light enters the glass prism, as you can see, this is the path of light. So PE is the incident ray. You can see here is P. So PE is the incident ray. And when the incident ray strikes the glass surface, then if we draw a normal which is perpendicular, so NN dash is the normal. You can see NN dash is the normal. So this is going to move towards the normal. So it is going to move towards N dash. Hence it moves towards N dash and then it emerges straight and parallel to the base. Okay, the ray refracts and emerges parallel to the base, right? This is the angle of refraction, this is the angle of incidence, and the refracted ray emerges parallel to the base of the prism, right? Then finally it strikes the other side, surface, the end surface of the prism at suppose some F. Then at F, again if you draw a normal MM dash, then again it is going to move from glass to air. So it's moving from a denser medium to a rarer medium. Hence it is going to emerge away from the normal. So you can see that it is going to go away from the normal. See here? And this is going to be the angle of emergence. Okay. So angle of incidence, angle of refraction, angle of emergence, right? So it's going to emerge like this. And can you see that the emergent ray is not parallel to the incident ray, as in the case of a glass prism. In the glass prism, it emerges parallel to the incident ray. If you see in a glass prism, when light comes here, okay, it moves. If you see, it's going to move towards the normal, and then after that if you draw another normal, it is going to move away from the normal. So you can see that here it is emerging parallel. Actually the diagram is not so accurate, that's why. So you can see here that it emerges parallel to the normal, parallel to the incident ray. The emergent ray is parallel to incident ray in the case of a glass slab. This is for glass slab. But in the case of a glass prism, a triangular glass prism, you will see that it does not emerge parallel to the incident ray. The emergent ray is not parallel to the incident ray. Okay, then here are the markings. So basically, to prove that, see, you can extend this emergent ray backwards. See this dotted line going from F to G? Let me mark it. So this line going from F to G, and it is an extended line basically. It does not actually happen. It's just that I'm extending it backwards. So when it is extended backwards, it meets extended. It meets the extended incident ray. It meets the extended, because this is the extension of the incident ray PE. So it meets extended incident ray at a point G, and then an angle is formed between the two. This is D. This angle D is called the angle of deviation. Angle of deviation of the prism or of the light ray. Okay, so that's your angle of deviation. You can see that this angle D is formed, and it is basically denoted by sigma. Okay, by delta, by delta. The Greek letter delta denotes angle of deviation usually. Okay, so I hope that's absolutely clear. That is the explanation of refraction through a glass prism. The light ray enters, then it emerges parallel to the base of the prism, and then ultimately it moves away from the normal and does not emerge parallel to the incident ray. Coincidentally, if you extend it backwards and if you extend the incident ray, they will meet at a point where they'll form an angle, and that angle is called the angle of deviation of the prism. Right? I hope that's absolutely clear, and that is all with refraction through a glass prism.